The Egyptian pyramids were built of reagglomerated limestone, a type of limestone concrete. I am a member of the International Association of Egyptologists, and I presented this theory since 1979 in the Second Congress of Egyptology in Grenoble, which was followed in Toronto in 1982, then in Cairo in 1988, and in Grenoble in 2004. What I am claiming is that the stones of the pyramids are not carved, but re-agglomerated. This is proven by science, experimentation, religion, and hieroglyphic texts. In order to present the theory in a very short way, we have a small video that will show the different aspects of the system.
ARICAT, the proven fact on how the pyramids were built. At last, a logical explanation of how the ancient Egyptians built the pyramids. An astounding discovery reveals they were not built by 200,000 workers or by aliens from outer space. According to archaeologists, the stones were all carved from nearby quarries, hauled on sledges, hoisted on huge ramps and set in place by armies of workers. To lift a 30-ton block off the ground would require the force of at least 1,200 men. They would have built a ramp, whether circular or straight, over 1 kilometer long, that required more material than the pyramid itself. And they ended up with some sort of traffic jam, until each block was placed in its position. However, recent scientific studies discovered the presence of artificial elements in pyramid stones. They found traces of a chemical reaction, more precisely, a geosynthesis, namely, the manufacture of minerals with chemistry. Thus, Egyptians built the pyramids using man-made stone, which looked exactly the same as natural rocks. Limestone blocks were cast in place. French scientist Professor Joseph Davidovits, chemist, geopolymers and ancient cement expert, solved the enigma. He sensed the truth when he found air bubbles and fibers trapped inside Great Pyramid's limestone. He discovered fossil shells in disarray, jumbled, not in normal sedimentary horizontally layers. He confirmed the existence of the lost technology in the artisan steel, currently found in the Louvre Museum. And also with enigmatic stone vessels found in the labyrinth under the Saqqara pyramid. The mystery was finally solved when he decoded hieroglyphs found in an ancient stele at Sehel Island, near Aswan, in the midst of the River Nile. It contains the chemical formula used by High Priest Imhotep to make the stones of the first pyramid in history, the Step Pyramid at Saqqara. Using the same formula and the same ARICAT stone technology, Professor Davidovits replicated several artificial limestone blocks in his laboratory at Saint-Quentin, near Paris. They looked exactly the same as natural limestone. The great Imhotep, the alchemist and master architect of Pharaoh Djoser, made the stone blocks and built the first pyramid at Saqqara. He invented the ARICAT stone technology, and here's how. Nearby the pyramids, pools were dug in the soft limestone along the Nile, forming basins for producing limestone concrete. Workers began disaggregating the crumbly rock with water coming from the River Nile. They flooded the canals to form a mud with clay. Next, sodium carbonate, called natron salt, was poured in. This salt is a very reactive substance. It is mixed with ash, rich in calcium oxide from burnt palm trees. When added to water, the resulting mixture forms caustic soda, which will trigger off a powerful chemical reaction. Then, workers added more limestone rubble and another salt, magnesium chloride, named carnallite, to lower the pH. After evaporation of water, the concrete is now ready. The limestone paste is taken in buckets, then carried to the pyramids. Archaeological digs discovered that only 2,500 people were working on site. In fact, the reagglomerated stone theory doesn't need more workforce. By means of wooden ramps and the tiers already set, men carried each bucket and poured its content into molds. Then, limestone concrete is compacted and left to harden. Wooden molds had been prepared. These molds had been smeared with oil to ease the release of the block once hardened. The mixture was rammed into the molds as in the making of the packed earth called pisé, becoming a strong and dense reagglomerated limestone. The workers stood inside the mold, pounding the wet material with a wooden pestle, packing it against a contiguous block already made, thus producing a close fit. That's how Imhotep's successors made millions of blocks for Cheops' pyramid, one of the seventh wonder of the ancient world. The ARICAT technology uncovers a logical, simple, and proven solution to the mystery that has puzzled man for centuries, shedding light on how the pyramids were really built.
The idea seems very plausible. However, when you arrive on the site, this is what you see. You have remains of carving activities. Here, for example, on your left is the pyramid of Cheops, and on your right is the pyramid of Chifren. And in between, remains of carving activity, which leads Egyptologists to contradict Davidovit's theory. The problem is that they never mention that above these quarrying remains, here we get a beautiful hieroglyph that belongs to the pharaoh Ramses II that came on the site 1,400 years later, which means that the quarrying remains do not belong to the pyramid time. And this is a problem. However, Egyptologists and geologists agree with the locations of the quarries where the material, the stony material, is coming from. We have located the Cheops quarries at Giza, and this is where they are. And if we look at the layers, we see that the materials was extracted in a very weak limestone that is absolutely not dedicated to the purpose of making building blocks and building quarters, but it is this layer of soft limestone that was used to build the pyramid of Cheops. And we see there are other quarries that have been used for the pyramid of Chifren and Mykerinos. So we know the location of the quarries at Giza. This is a cross-section of the plateau. You see where the quarries are located. This is in the wadi, below the plateau where the pyramids have been built. The quarries are not close to the pyramids, they are below, and this is strange. And this is confirmed by geochemical analysis made by Professor Klemm from the University of Munich in Germany that shows that analyzing the various blocks from the pyramids of Chifren, Cheops, and Mykerinos, he found that, for example, for Mykerinos, 100% of the stone is coming from a quarry that is in the wadi, below. For Cheops in yellow, 72%, from Chifren 44%, but from the base itself, that is the location where the pyramids are, where they have been founded in the very good limestone bedrock, practically 0%, 3% for Cheops, and 2.5% for Chifren are coming from that era. All the others are coming from quarries that are in the wadis, which means that practically 98 to 100% of the stones that are constituting the Great Pyramids are coming from this soft limestone layer. And if we look at the satellite view, we see that for Cheops and Chifren, we have a level of 54 meters for Cheops, 56 meters, and the quarries are located below at 20 meters or 19 meters above sea level. And if we go to Chifren, then we climbed up to 72, and we see that on the left of the pyramid site, it goes higher. The geological limestone layers on the left of the pyramids are higher. It would have been logical for the Egyptians to take these very good limestone bed that is located up the pyramids to get the limestone to be quarried, put on sledges going down hills to the pyramid site. It would have been easy. No. What they have done, they made just the contrary. They got their stones from the quarries that are located below the level of the pyramids, and they had to go up to the quarry, to the pyramid side, which means they had to add another burden to their work that they had to accomplish. This is against nature, and this is not how Homo sapiens would have reacted. Remember, all other quarrying activities that we find in Egypt, essentially in the south of Egypt, in the Sinai quarries, in the granite quarries, and so forth, the quarries are always located above the site where they have been used. This is logical, and this is always the same way that had been used later during antiquity. The quarries are always located above so that the stones could be transported on sledges downwards very easily to the site. Here in Egypt, it is the contrary. This is strange, and we will see other strange things at Giza that shows that the normal way of thinking must be revisited and revised. For example, we have huge blocks that have strange lift lines, layers that do not fit with geological layers. Then we see a block, a piece of stone, here practically 30 centimeters long, that is inside another limestone block. Nature is not capable of doing this. And if we look at other blocks, at the Pyramid of Chifren on the south side, then we see huge blocks that have curved joints and very strange curved joints. This is impossible to get with the regular carving tools and with the regular way of making the blocks as it is presented by Egyptology. And we continue to look at the variety of strange things that we see on the site. Here we have the level, the horizontal level. Beneath here are the natural limestone bedrock that is inclined, going from the west to the east. And if we look at the nature of the nummulitic shells that are constituting the limestone in Giza, then we see that the natural limestone is made of fossil shells that are horizontally aligned, this is quite obvious for natural nummulitic limestone. And if we look at the pyramid blocks, we have these shells in disarray, which is not very oftenly found in natural limestone. So there is a big difference between the natural geological limestone and other pyramid blocks. So we claim that the blocks were not carved but re-agglomerated. This is proven by science. Which science? Well, this is the science of geopolymers. And you know that this science is young. It is only 30 years young science. And it is obvious that it takes time until the knowledge coming from geopolymer chemistry is adopted by other fields of activity in the university, and especially in the world of history and here precisely Egyptology. So we have geological analogues, SiOAl, aluminosilicates, silates. We have systems that belongs to natural geological minerals such as calcite, sodalite, cyanidine, or leucite, or anorthite type. These are the results of various geopolymerization. So you know that we are capable of making binders that have the properties of the makeup of natural minerals. We have developed with these system applications such as geopolymer resins, geopolymer cement, foam, composites, and of course geopolymer stones. They are applied as fire and heat materials, as cement and concrete for building materials. We are using the geopolymer chemistry to mitigate global warming, CO2 emissions. Geopolymers are used for environmental technologies, the containment of toxic waste. And we are applying the science to study archaeological artifacts. And since we are dealing here today with archaeology, we will be looking at Egypt. So we have antique geopolymers. These antique geopolymers must follow a prerequisite. They must be easy to implement. We must have mineral resources in great quantities. This is a technology that is not concrete. It is not regular gypsum. There is no cement added to the system, and we are not using crushed stone. On the opposite, we are using the knowledge from geopolymer, from geosynthesis, from geochemistry, from mineralogy, from geology, and we are using naturally weathered stone instead of crushed stone. In the case of the Giza material, we have an agglomerated stone that is a mixture of 95 to 97% by weight of limestone that are shells, fossil shells, and calcite, to which we add 3 to 5% by weight of a geological glue that is a geopolymer. So this will explain why geologists see nothing. You'll see in the literature dealing with the contradiction of my theory, and you see in several papers written on the internet, that it is very easy to look at a stone and to detect if it is a natural or an artificial one. Wrong. This is not the case for geopolymeric limestone, and it is not the case for the Egyptian limestone blocks that are making the pyramids. And I have to show that, in fact, each time that geologists or mineralogists are looking at this type of stone and claiming it will be very easy to detect that they are not made of the system that I am claiming, that is reagglomeration, they fall in the pitfall of the thin section optical analysis. What is the problem here? The problem is that we are dealing with a material that is an aggregation of fossil shells. You see here the shells that are constituting the pyramid blocks. We have 95% of shells, and in between a very tiny amount of the binder that is called micritic binder. So when you make a thin section, it is obvious that what you see are the natural elements, that is, the shells. 95% of what you have under your microscope lens is natural shells. And we are just discussing the 5% that are constituting the micritic binder, the geological glue. And if you don't look at the geological glue very precisely, you see nothing. At the beginning, I had to study some stones, some genuine stones, and I discovered on this lower sample here the presence of strange artifacts that I called filaments. And then we have a lot of air bubble. This is a stone that is covered with a synthetic coating. This was in 1982, and then after, for several reasons, essentially after 1990, I stopped doing any research on this material, and it had been only on the year 2001, 2002 that we started again to reconstitute limestone blocks like the ones that we find at the pyramids. And we made several limestone artifacts in the laboratory, and we will see later in great quantities. And we took these reagglomerated limestone made in 2002 to two different geological renowned laboratories in France. The first one was the Bureau de Recherche Géologique. This is the RGM, this is the French Geological Survey. And the second at the Museum of Natural History in Paris, at the Geological Department. We gave them two samples of the limestone that we had reagglomerated in our laboratory at the Geopolymer Institute in Saint-Quentin, France. And we told them, look, we found this type of limestone. They seem to be strange for us. Could you tell us what it is really about these stones? They made a thin section. They wrote a report. And this is what they got. This is the thin section of what we gave them. Obviously, you see the big numelite, then other natural artifacts like the quartz or the echinids, and in between the micritic binder. The micritic binder is a binder that it made of very small particles of calcite, and they claim that this was the thin section of a natural nummulitic limestone. This piece of artifact was made in our lab and had up to 10% by weight of modern geopolymer. They could not detect it under the optical microscope. The binder that we used to reagglomerate the stone had been claimed to be natural micritic binder. So if I don't tell that the piece of limestone has been made in our laboratory, geologists and mineralogists will state that it is a natural stone, and this is also the case for the samples that we got from the Egyptian monuments. So I asked my scientific colleagues to look at a way in order to try to determine the artificial nature of the micritic binder, of the geological glue. And the only way to do it, the practical way to do it, is to use electron microscopy. This has been done recently by a group of 3 scientists: Michael Barzoum, Gangli from Drexel University in the US, and Gilles Hugues from the CNRS in Paris in France. They published in December 2006 in the Journal of the American Ceramic Society the results of the analysis under electron microscopy, and they claimed microstructural evidence of reconstituted limestone. Well, they got 6 natural samples that came from the quarries. We compared Egyptian monument stones with natural quarries, where they usually seems to come from. And they got 5 pyramid samples, 3 from Khufu, Cheops pyramid, and 2 from a satellite from Menkaure pyramid that is called Menk. And I will focus on this one because it is the prototype for the core blocks, that is the mass of the material that is constituting the pyramids. So this is where I took the Menk samples. This is one of the pyramid. This is the second one here. And this is the place where we got the samples. This is the Menk samples. It is a piece of a big ashlar. And under the electron microscope, we got the following analysis. As you see, it is a mix of sodium, silicon, aluminum, magnesium, calcium, carbonate, and chloride that represent NaCl, Si6Al4MgCaO14, 6 calcium carbonate. It is an aluminosilicate of geopolymer that has also natrium chloride and calcite in it. The authors confirmed that the matrix was the result of geosynthesis in high alkaline milieu, pH 13 to 14. And I'll present now the various chemical steps that have been used by the Egyptians in order to make the reagglomerated limestone. These are the steps that are exactly in agreement with the analytical results. The first reaction is the use of sodium carbonate, natron, that react with lime, produce caustic soda. This is the basic of the geopolymeric reaction. And you see that we have also the production of calcite. So you see the first step of using this chemical reaction is the making of a natural mineral, calcite. Then caustic soda is reacting with canolytic clay. This is one of the basis reactions that we know in geopolymer chemistry, and we get what are called here anhydrated feldspathoid. The pH is around 13 to 14, and if instead of sodium carbonate in reaction 1 we have sodium sulfate, then we will get caustic soda and the production of calcium sulfate, which would be then taken by geologists or mineralogists for remains of gypsum, which is not. The fact is we need lime. Sodium carbonate is a salt, this is natron, and we have to manufacture lime. And this is a debate between Egyptologists and ourselves, and we will come and discuss in detail this feature later. Reaction 1 and 2 were the two reactions that I frequently used in our lab, and I thought that this was sufficient. However, I was always struck by the fact that we still were in high pH, and I was always wondering how the Egyptian workers were dealing with this corrosivity. Until I got the first results of the electron microscopical analysis from my friends Barzoum and Hug. The first result was that they did not find remains of natron, sodium carbonate. If the chemistry was right, we must have remains of sodium carbonate. They did not find it. Second, they did not find the aluminum silicate, sodium aluminum silicate, what I was claiming. And this was a little disturbing. But instead of sodium carbonate remains or aluminum silicate, they got sodium chloride and magnesium aluminosilicates. So I had to cope with this fact and to figure the chemistry that could yield to these two minerals. And I came with the addition of another salt that is always found with the first one, with natron, that is magnesium chloride, carnallite and the likes. And I discovered a very simple reaction. That is, when you add this magnesium chloride into the system, it neutralizes it first, and then we have an exchange of the sodium with the magnesium, and we get a new material, a new element, a magnesium aluminum silicate. This is exactly what they found in their analysis, and with the production of halide, of sodium chloride. Well, the addition of this magnesium chloride, that is a very common salt also in Egypt, has two major effects. The first one, it lowers the pH because it neutralizes the caustic soda. And the second, it transforms the sodium aluminum silicate into the magnesium aluminum silicates found by the analysis. If we make the pH, if we measure the pH of the slurry here, we see essentially if we take a paper pH chromatography called behavior, the pH of the liquid is around 9 instead of 13, 14, whereas the pH of the paste is between 12 and 13. So we have a strong neutralization which able the workers to take the material with bare hands and bring it to the site. Well, if we continue and if we have an excess of all these starting elements, such as sodium carbonate, then it reacts with the carnallite, with magnesium chloride, and we have production of magnesium carbonate, magnesite, plus halite. And this is very interesting, because if instead of sodium carbonate, you have the production in the mix of sodium silicate, which happen if one gets in the mix soluble silicae that will react with caustic soda, producing sodium silicate. Then the sodium silicate will react with magnesium chloride and will be transformed into magnesium silicate, another element also found in the analysis. So to sum up, we see that we get the production of minerals that are analogues to natural elements, and then we have hydrated calcite on the top, hydrated magnesite, and both of them will interact to make hydrated dolomite that will later transform, crystallized into the beautiful rhombohedral crystals that are also found in the pyramid stones and in the mortars that belongs to this Egyptian epoch. As a summary, we have the action of the reactive products. On one element, natural, here it is clay, carnallite clay, could be also silicates, and we are producing natural minerals. So the chemistry is providing the formation of natural minerals, and it is this system that is used to make the geological glue that are 3 to 5% by weight constitution of the limestone that contains 95 to 97% of shells and calcite. And it is obvious that if geologists and mineralogists do not understand this chemistry, they see nothing. So we have two different geopolymer systems. For the core blocks, the prototype is the Menk stone. It is made of natrium, magnesium, calcium, aluminosilicates, plus halite, natrium chloride, common salt, dolomite, and calcite. This is the micritic binder. And for the casing blocks have up to 10% of silicae in the constitution, which is a lot for the geological glue, and are represented by the samples we got from Cheops and the Laowa stone. It is magnesium silicate, sodium chloride, dolomite, and calcite. The scientific results for this geological glue, which is the micritic binder detected under the optical microscope, is made of what they called microconstituent containing silicon, calcium, magnesium. And here we discover that we have a geopolymer mechanism that is involving calcium and magnesium. So far, we did not have a system in which magnesium was directly involved. And here it happens by ion exchange between sodium and magnesium. In addition, we have hydrated calcite and hydrated dolomite. These two elements are unknown in nature. In nature, they are crystalline. And we also have aluminosilicate clay types that are amorphous. In natural stones or in natural materials, they are always crystalline. These results prove the artificial nature of the micritic binder. You'll get additional information in chapter 17 of my book, Geopolymer Chemistry and Applications. The stones of the pyramids are not carved, but reagglomerated. This is proven by experimentation. We had the system, so we decided to experiment it in making great quantities of stones, not just in the lab, but also outside. We had to choose a material that would be equivalent to the one that is found at Giza. So this is the cross-section. You see in yellow the soft marley limestone layer that had been used for the buildings of the pyramids. These quarries are supplying a nummulitic limestone that is unique for the Giza plateau, and we had to find near the Cinquanten a geological outcrop where we could get something similar. We had the luck to find just south of Cinquanten a quarry where we got this nummulitic limestone, and we decided to make 15 tons of pyramid stones. And since it was an experiment, I choose to vary the various parameters that are involved in the making of the blocks, namely the amount of water, the amount of clay that we had to add to the limestone because it did not have it. It was inherent in the Giza limestone, but here in the French limestone we did not have the clay, so we added the Carnottic clay, 4%, and the chemistry, which are the limestone and the likes. So we changed the amount of the elements in the various blocks that we made, and we will show you a small video of this experimentation where we produced 15 tons of reagglomerated limestone.
In September of 2002, our Geopolymer Institute crew cast massive imitation pyramid blocks. Or perhaps we should say genuine pyramid blocks. We used the same kind of earthen ingredients available to the ancient Egyptians 4,500 years ago. These massive blocks have the same chemical makeup and appearance as blocks of the Great Pyramid. The limestone we used consists of fossil shells called nummulites, like those in the Giza bedrock. Like in Giza, our French limestone is so loosely bound it doesn't require crushing. But unlike in Giza, it contains no kaolin clay. We heap the cement additives, lime, natron and kaolin clay, near the limestone.
The two components will react in the water and build in situ geological glue, which will then yield the hard geopolymeric reagglomerated limestone.
We start making the cement by mixing sodium carbonate, found in Egyptian natron, and lime in 500 liters of water. We then add the kaolin, inherent to Giza limestone, and stir the mix with a wooden tool. We dump 1 ton of limestone rubble into the basin and mix it with the cement. Several days later, water has evaporated from the basin, so we remove the disaggregated limestone for making the block. Inspecting the mixture, 95% limestone aggregates and only 5% rock-making binder. Between 12 and 17% of water give it the consistency of wet sand. One squeezes the mixture with his hand and it keeps its shape. This batch will quickly gain strength. We do all of the work manually, forming a human chain carrying buckets from the mixing area to the mold. We pour the limestone concrete mixture in a mold and pack it down with a tool called a rammer. Compacting the material requires little effort. The packing operation encourages cohesion and the denser mixture takes on high strength from the initial curing phase. When the climate is warm and beautiful, our crew rapidly produces a re-agglomerated limestone that proved strong, dense and true to the plant's size and shape. The mold consists of small wooden boards, which can be reused many times for making other blocks. In this ideal weather, the whole process runs smoothly and is very simple. We remove the mold 4 hours later. The synthetic limestone looks like a natural stone. We observe no trace of wood grain. 4 blocks have already been made. Joseph Davidovits presents them. The 2 large blocks weighing up to 4.5 tons, containing most water, have given smoother surfaces. The 2 small blocks weighing up to 1.3 tons, the least wet, take on rougher surfaces.
When you look at the stones of the pyramid, this is what you see. You see either smooth blocks or very crude blocks. And we have replicated all these surfaces just by varying the amount of water, which depends on the climate, which depends on the weather.
Joints between blocks are also perfect. It will take 3 months for the stones to fully cure because of the climate of northern France. In 4,000 years, will future archaeologists insist that our imitation pyramid stones are natural limestone?
We looked at the stones 1 year later, and our scientific team gathered in Saint-Quentin to examine the material. We had protected the blocks against the rains, against the frost. The climate in northern France is not the same as the climate in Egypt. In Egypt, it practically never rains, and it practically never freezes. In France, we had, in January 2003, 1 month long freezing, which is not very good for this type of stone, but this is how it looked like when we reopened the molds and the shelters. So we got our blocks that were in good shape, and we were starting to look at them. You remember in the video we have been claiming that we cannot see the joints between the stones. Well, 1 year later we have the joints, and this is obvious because each block during hardening is shrinking. The shrinkage is very small, but it is sufficient to produce a joint between the blocks, and each joint in fact is the mirror of the other. They are perfect and they are exactly in the same shape at what we see on the pyramid site. But above it, you see that the stone above the two others, we don't see practically any joint, and we feared that the blocks would be glued together. This is what people are always telling to us. Well, if you are doing this type of experiment, your stones will glue to the other one. We had to destroy what we had manufactured, and during the crushing, and we were capable of, in fact, separating very easily the upper block with those from the bottom, and we saw that they were absolutely not adhering to one to each other, but that in fact the surface of each blocks were exactly fitting with the surface of the other one. And this is also one of a very specific feature of the pyramid blocks. The blocks on the horizontal layer are absolutely fitting to one to each other without any space in between. So we can claim that our experimentation was very fruitful, and it provided good knowledge into the practical feasibility of the system. Well, the stones were not carved, and this is proven by religion. In Egypt, everything is connected to religion. Every item, every part of life is connected to a god. And here it is obvious that the building of these monuments must have a religious meaning. And we discover that, in fact, there is one theorem that is never taught by Egyptology, but which is obvious. And this, I call it theorem number 1. The stone has a religious meaning. Stone is used only for tombs, pyramids, and temples. Stone is never used in secular constructions, never for palaces, garrison, houses that are made out of wood, clay, brick, never in stone, except during the Greek period, during the invasion of Egypt by the Greek, and they started to build Alexandria with stone, and except during the Roman occupation. So never during the genuine Egyptian civilization was the use of stone permitted for secular constructions. If you want to explain this dichotomy, that is, stone for temples and clay and wood for regular buildings, then we discover that at the roots of this Egyptian civilization, we have two genesis, two genitors, two ways of creating man. The oldest is the one of the god Khnum, and the youngest is the one of the god Amun. We have two antagonistic religions that will be sources of rivalry, and two different technological civilizations that will support these religions. Let us start with the god Khnum. The god Khnum is depicted by a ram-headed man, and you see here the horns are particular. These are horizontal horns, and you see the god Khnum on his potter wheel, and he is creating the body of the pharaoh and his car, his eternal soul, by petrifying, by using clay. The creation, according to the god Chnum, he creates humanity and the gods with clay and silt. You know, this is the Genesis that we are accustomed to read in the Bible, and it is also the type of Genesis that is depicted in the Quran. The god Chnum, he creates the car of Pharaoh. The car is the soul in eternal stone. For the god Chnum, creation is the divine incarnation in the agglomeration of stone. And we discover that for Cheops, for the builder of the most impressive monument of antiquity, the actual name is Chnum Khufu. May the god Chnum protect Cheops. Well, the god Chnum is associated with the building of the pyramids, and the pyramids must have been done within the technology associated with Chnum, which is agglomeration. On the other side, for the god Amun, it is different. A mountain of mud began to rise up from the shadow's waters. The mountain of mud swelled up, casting out bubbles, and took the form of the first god Amun. And Amun pulled out, carved the limbs and all the parts of his body, and these parts of the body of Amun were transformed into man, animals, and all creation. This is different. For God Amun, in the creation, he carves mankind and the other gods in his body, the mountain. The creation is the divine incarnation in carved stone. And we understand that Ramses II had his temple at Abu Simbel digged out in the body of Amun, in the hill of sandstone. And we understand that the temples in Thebes, in Karnak, in Luxor were made of carved stone that had been cut very carefully in the body of Amun. And we understand why the obelisks out of granite have been called the finger of Amun. So we have two civilizations, one in the north that flourished during the Old Kingdom, god Chnum, agglomerated stone, and that in the south that flourished under the New Kingdom, god Amun, and carved stone. The stones were not carved, but reagglomerated, and this is proven by hieroglyphic texts. This is the first theory that is based on hieroglyphic texts. We have discovered the text that depict this system. Remember, Egyptology has never found any text proving that the pyramids were built with carving stones that were hoisted on sledges and ramps. There is no text. And they say there is no text because it is a sacred system that should not be revealed to anybody. Well, we are here dealing with technological text, with texts that are describing technological informations. And you know that it is very difficult to translate a technical text into language if you are not aware of the signification of the keywords. I will provide here a small example that is well adapted to our speciality, to our geopolymeric speciality. Let us imagine that I got a text from Egypt that has been translated in the following way. The text says, I make fluid stone with ashes, insect in glass water. Well, you have this text, and it has been fluidly written to say fluid stone could be cement. So we write, make cement with ashes from flies, these are the insects, in glass of water. This means nothing, whereas what we have in reality is the description of to make a cement with fly ashes and water glass. So this is the example that you have to be in front of you when you will be trying to understand the antique texts that are dealing with our technology. So we have the text, and the first one is a very renowned text that is called the Famine Stele at Sehel. It was engraved in 2000 BC, that is more recently, but it is understood that it is a copy of a more ancient text dating to the time of the pyramids. And what we have here, we have the pharaoh Giza, the builder of the first pyramid, that is worshipping the god Khnum. And we have the Famine Stele is in fact a list. There are 32 columns in which 1/3 are dedicated to the lists of minerals that will be used to make the pyramid. In text, in antique text, what is very difficult to translate are verbs. For example, here we have the verb ericat, which means to create, to manufacture. This is the verb that is used to depict the god Khnum when he is making, when he is creating, manufacturing the car that is the soul of the pharaoh in eternal stone. And we find this verb, ericat, in the Famine Stele, where the god Khnum is providing the minerals to Pharaoh Djoser to build his first pyramid. And this is here on the right. You see ericat, to manufacture, and the real translation is, since creation, you are the first one who manufactures them, the minerals, to build the temples. The second verb is the verb chusi, that means to erect, to build, to construct, and you see that the verb has a determinative that is a man pounding something in a mold. So this is the making of an agglomerated stone, this is the making of bricks, and this is the making of stone. That this is what we are dealing with. Chusi, to build in reagglomerated stone, and this is what we get as sentence in the Famine Stele, with these products that are depicted in the various columns in hieroglyphs. They have built the pyramid, the royal tomb. Which pyramid? It is the first pyramid, the one of Djoser, that was built by Imhotep, one of the greatest scribes in Egypt. It is the first pyramid, the step pyramid at Saqqara. The step pyramid at Saqqara is made of small limestone bricks that have been manufactured like crude clay bricks. They took the molds, made the bricks, transported them, and laid down the pyramid. In fact, they use the same technology that had been in use previously in the making of their monuments and the enclosure. Here it is the enclosure of Khasem-Khemui, the pharaoh that was just before Pharaoh Djoser. My opponents always claimed that if the reagglomerated theory was correct, the blocks made in molds must have the same dimension like it is for clay bricks. Well, here we have the example of the Khazempremwe enclosure, and if we look at the dimension of the clay bricks, we discover that they are not equal. We find at least 5 different dimensions, which means that the 5 different dimensions were decided by the architect, because in fact it is the only way to get seismic resistancy, seismic durability for monuments that are built in earthquake-prone areas. So the Egyptians had this knowledge at their disposal. So it started with the first pyramid in small bricks. They mastered the technology, improved the dimension of the blocks, and they ended with the first pyramid of Seneferu, that is the rhomboidal, where the blocks are still moved, still transported to the site, but they are becoming to be too big. And for the red pyramid of Seneferu, they are too big to be manipulated, and they are cast, they are pounded on site. We then arrive to the Giza plateau, where this technology was used for the Cheops, Chifren, and Mykonos pyramids. So it should have evolved in this way during the entire civilization, but in fact we observe a dramatical stop of the technology. If we look at the variation of the pyramid's volume with the time, with the dynasties, then we see that from the invention by Djoser to the Cheops pyramid, that is practically within 60 years, we have an increase in the volumes of the pyramids, optimum by Cheops and Chifren, and then a dramatic plunge, a dramatic decrease of the volume by Mykonos, and the others are ridiculously small. What happened? This is what we will try to explain now. And in fact, we can interpret it with 2 elements that are part of the industrial activities. First, we may suppose that there have been exhaustions in the Sinai mines. Some minerals are used to make artificial stones, and we have text, we have records that shows that at that time the Sinai mines were very heavily exploited, and afterwards no longer. Or the manufacture of lime ash generated an ecological disaster. This is the lime that is intervening in the reaction number 1 that we need in order to get the reaction between the natron, sodium carbonate, in order to produce the caustic soda that will start the geopolymeric reaction. Well, lime is very important, and it has been shown by Clem that in the 6th dynasty, lime disappears nearly within the waters. May this be interpreted as a variation of accessibility of fuel, of wood, and consequently of economic potential and crisis? For Professor Clem, he was talking about the regular lime that is calcined from limestone in kiln. The problem is that we have not found any remains of kilns in Egypt to manufacture or to build the pyramids of Cheops and Chifren. We need approximately 150,000 tons of lime, which means that we should have found remains of kilns that were producing this lime. We did not find them, which means that the technology was different. And the technology was different. It was the one of the ashes that contains lime that were used in other reaction. That the ecological disaster came from the overexploitation of the wood. This is proven by the fact that just after the Great Pyramids, one get frescoes that are describing famines. So something very dramatic and tragical happened. And if we want to understand what was the reason, so we have to come back to one essential knowledge, that is the one that plants were supplying a lot of chemicals during antiquity and even during our Middle Ages in Europe. If we look here at the ashes that are the results of the burning of wood or plants, you see that we get plenty of SiO2 that is chemically available for the reaction, plenty of CaO, calcium oxide in beech, oak, acacia, palm trees, plenty of alkali, K2O, in beech, in palm trees, in fern and bulrush and so forth, which means I am claiming that this is the way how they used the plants and the woods in the manufacture, in the production of these ashes that have been the sources of the chemicals. And it is obvious that if they overexploited the palm trees in the production of the ashes that contains the silica and the calcium oxide, then they got into an ecological disaster, because the palm trees are always associated with agriculture. If there is no more palm trees, there is no more agriculture. And it can have been the end of the pyramid construction. It was obvious for the Egyptians that this technology, even if it was a sacred one, was dangerous. Just after, what we have is the starting of making a small pyramid in carved stone. And if you want to have pyramids made of carved stone, this is what we have. We have here the pyramids of Userkaf, 2460 BC, which is just after the pyramid of Giza. It is just a heap of small stones that have been taken from the environment. And if you compare it with the first one, you see this one is totally destroyed and this one is still there. So this is a big difference between a building made out of reglomerated stone and a small building made out of carved stone. So if you want pyramids made of carved stone, this is what you have, and you see that it is no longer this very powerful and very important technology that had been used previously. And if we continue to look at the Egyptian civilization, we are discovering something which is really very strange. So we started with mud bricks that were used in the enclosures during the Second Dynasty. They did not have stone tools, so it is obvious that they used mud bricks. Then it was the invention of the first limestone bricks by agglomeration. The technology improved into bigger and bigger and bigger blocks, limestone blocks, and then suddenly, 800 years later, they had the bronze tools to cut their stone. No, they returned to pyramids made of mud brick. So this is something that Egyptology is not capable of explaining. It is something that geopolymeric technology is capable of explaining, essentially because here we had a stop of the use of this technology to make stone, and they turned back to mud, because mud bricks is also the replica of reincarnation in the materials that belongs to the Chnum divinity. Well, what about the Cheops pyramid? You have seen I am talking about the pyramids and I don't talk about Cheops. Strange. Well, if we look at Cheops, this is what we have. We have the core, this is the mass, more than 2 million tons, is made of limestone, re-agglomerated limestone. But here in inner, there is one exception. It is made of granite. It is made of carved stone. Why? Cheops, you know, is Chnum Khufu. Well, it is agglomerated stone. However, Pharaoh is the king of the two countries. And it is obvious for me that the pyramids must be the representation of Egypt, must represent northern country and the southern part of Egypt. Which means we must have a replication of agglomerated stone for the northern part of Egypt, and in the south, natural granite, that is the carving technology. So we have agglomerated limestone for the core, and the king chamber is made of split granite that is dressed. Split granite, not carved granite. And I have to figure that it have been two independent building sites that were not connected between each other, and that those who were involved in the erecting of the natural granite slabs, these are huge, were using a temporary ramp that was located on the south side of the pyramid, on the opposite of the Grand Gallery. So we had two separated technological work sites that were working independently. For Chifren, same problem. The core is made of agglomerated stone, but this time they used the granite in a very more easily way. It was only for the casing of the first and second steps, that is made of split granite, like this one. These are blocks of granite that are split into two and are incorporated into the natural layer, the natural step. What about Mykerinos? Mykerinos has a core made of agglomerated limestone, and the first steps were recovered with a casing already also made of split granite, not dressed. We are not alone. We have several institutions that officially are claiming that they support and they endorse the agglomerated limestone theory. Very famous institutions, and they are supporting us. And in fact, if we look at the world connection of the Institute Geopolymer, of the Geopolymer Institute, it is obvious that there are several institutions in the world that are agreeing with this theory of the pyramids being made of reagglomerated limestone. You'll find additional information in my recent book, They Built the Pyramids, and also in the book Geopolymer, Chemistry and Applications.